Hi, welcome to Math 100. This is the first part of today's lecture. We'll be talking about limit of a function and limit theorems. Let us begin by considering this rational function f of x equals 2x squared plus x minus 3 all over x minus 1. Then the domain of this function is the set of all real numbers except the set containing 1. Hence, f of 1 is undefined, or f of 1 does not exist. However, let us ask ourselves this question: what can we say about the values of f of x for values of x near 1 but not equal to 1? And to answer that question, let us consider the following. F of x is this function, and our numerator can be factored out as follows. It is also 2x plus 3 times x minus 1. And since x is not equal to 1, this is non-zero, and we can cancel this out. And we are left with 2x plus 3 if x is not equal to 1. So f of x is also equal to 2x plus 3 whenever x is not equal to 1. And let us answer our question. Ano daw yung values ni f of x for values of x near 1 but not equal to 1? Let us start with x's near 1 but less than 1. And start with 0. When x is 0, ano ito? It is 3. And then work our way papunta kay 1. So tataas ito, aakyat papunta kay 1. When x is 0.25, ano ito? This is 3.5. And so on and so forth. When x is 0.5, this is 4. Hanggang pumunta kayo sa malapit na malapit kay 1, but not equal to 1. So when x is 0.99999, what you'll get is this number very close to 5. Next, let us consider values very near to 1, but greater than 1. Start tayo kay 2, and then pababa, papunta sa malapit na malapit kay 1. So when x is 2, from here you'll get 7. When x is 1.75, and you substitute 1.75 here, you'll get 6.5, and so on and so forth. When x is 1.5, what you'll get is 6. Hanggang pumunta kayo sa very, very near to 1, 1.00001, and you'll get this value very, very close to 5. So, anong na-observe natin dito sa graphs na ito, or sa tables na ito? According here, kahit si f of x undefined kay x equals 1, mukhang may pinupuntahang value sa f of x, ano? And the values of f of x get closer and closer to 5 as x approaches 1. Pero hindi nag-equal kay 1. And this is precisely the definition of limits. We define the limit of a function f of x as x approaches a is L. If the values of f of x get closer and closer to L as x assumes values getting closer and closer to a but not reaching a. And we denote this as follows: the limit of f of x as x approaches a is L. Ano nga ulit ibig sabihin nito? Ibig sabihin nito, habang si x daw palapit ng palapit kay a, pero hindi nagiging equal kay a, malapit na malapit lang kay a, si f of x palapit ng palapit kay L. Okay? So from our previous example, dito, si x mo palapit ng palapit kay 1, palapit ng palapit kay 1, kaya naman si f of x mo palapit ng palapit, this time kay 5. Hence, dito, limit ng f of x as x approaches 1 is 5. And, a very important remark, we note that the limit is unique. Ibig sabihin, itong limit na to, it is 5 and 5 only. Wala nang iba. Alright. Now, you might be asking yourselves, so pag kinuha ba ang limit, kailangan i-consider natin yung function values when x is very, very near to 1? Sabihin, talaga bang gagawa tayo ng tables na ito, tapos tayo ay magsasubstitute? And this is very tedious, no? So this is not the only way. Another way is by observing the graph of our function. This is the graph of our function. So may hole dito, no, sa 0.15. Ang tanong, paano natin kukunin yung limit given this graph? Ganito ang gagawin natin. Parang ginawa lang natin sa table kanina, no? Nag-consider tayo ng values very close to 1, pero hindi equal kay 1. So, sa simula, nag-consider tayo ng values very near 1, but less than 1. Nag-start tayo kay 0. Okay? Nag-start tayo kay 0. And then, pumunta tayo pataas kay 1. Tapos, kinonsider natin yung function value sa interval na ito. Ano yung function value sa interval na yan? When x is 0, ito yung function value. Papunta kay 1, ang function values ay ito. So, pumupunta siya dito, no, sa hole na ito, which is 5. Tapos, nag-consider din tayo ng values very near 1 but greater than 1, and we started with 2. Tapos, paliit ng paliit, papunta kay 1. Ano ngayon yung values niyan, function values? Mula dito, papunta dito, kay 5. So, nakita niyo yung function value natin, papunta kay 5. Therefore, the limit of f of x as x approaches 1 is 5. Okay? That's how we get the limit by observing the graph of our function. So, let's go back to our discussion. That's the limit. And we note that even though f of 1 is undefined, yung limit ng f of x as x approaches 1, nag-e-exist pa rin. So, yun yung maganda sa limit, no? Kahit undefined yung function value at that point, yung limit pwedeng mag-exist. Okay? So, now let's talk about properties of limits. Let a and b be real numbers and n a positive integer. Ibig sabihin, n is 1, 2, 3, so on and so forth. Then, we have the following. Yung limit ng b as x approaches a is, so saan papunta si b as x goes very, very near to a but not equal to a? Si b constant so independent of x. Kaya habang si x palapit ng palapit kay a, si b naman hindi nagbabago. So, it's still b. Next, saan papunta si x as x goes very, very near to a but not equal to a? Well, kay a. Next, saan naman daw papunta si x raised to n as x approaches a? And that is just a raised to n. And finally, saan papunta si nth root of x as x approaches a? It's just nth root of a, provided, of course, that a is positive whenever n is even. So, sa 2, 3, and 4, no, madali lang nag-substitute lang tayo. Sa 1 naman, retain lang siya kasi constant lang. Alright, let's have the following examples. First, hanapin natin yung limit ng pi as x approaches to. Pi is constant, so hindi yan magbabago kahit saan man pumunta si x. So, that is still pi. What about the limit of x as x approaches 12? Substitute nyo lang, is just 12. What about the limit of x squared as x approaches 3? It's 3 squared, or 9. And the limit of square root of x as x approaches 16, it's square root of 16 or 4. So, very straightforward. Direct substitution lang ang nagaganap for 2, 3, and 4. Okay? Next, let us talk about operations with limits. Again, let a and b be real numbers and n a positive integer. If the limit of f of x as x approaches a and the limit of g of x as x approaches a both exist, ibig sabihin parehong real numbers, then the following operations are valid. We can talk about the limit of sum of f and g. At ano ito? Pwede nyo i-distribute, no? Parang i-distribute yung limit. So, yung limit of sum will become the sum of the limits. Limit of f of g is just limit of f plus limit of g. What about product? Kapag product, ganun din, ano yung limit ni f times g? Parang pwedeng i-distribute ulit. So, limit of product is just product of limits. Next, ano yung limit naman ni b times f of x? So, yung b mo dito, constant. Pwede mong i-apply yung second bullet. Tapos, since this is product, you have limit of product equals product of limits. So, you'll have limit of b times limit of f. Pero ang b ay constant. So, ano yung limit of b? It's b. So, essentially, ang ginagawa nyo, inilalabas nyo lang itong constant. So, you have b times yung limit of f of x as x approaches a. Next, provided yung limit daw ng ating denominator ay non-zero, yung limit ng quotient natin ay quotient of limits. So, pwede yung i-distribute, i-distribute yung limit ulit sa numerator and sa denominator. Next, ano naman yung limit ni f of x raised to n as x approaches a? This time, pwede nyo namang ipasok itong limit. Ipapasok nyo lang siya sa loob so that you'll have quantity limit ni f of x as x approaches a raised to n. Similarly, kapag nth root naman, ipasok nyo lang din itong limit, no? So, you'll have nth root ng limit ni f of x as x approaches a. And this is again provided that the limit of f of x is positive whenever n is even. Okay? Another important theorem para makatulong sa pag-evaluate ng limits is the following theorem. Kapag ang p daw ay polynomial function at a ay isang real number, then limit of p of x as x approaches a, this always exists and is equal to p of a. So, anong nangyari? Ang nangyari lang ay, sinubstitute mo lang. So, parang ganun yung common thread, no? Pag kinukuha mo yung limit, parang nag-i-evaluate ka lang din. Substitute ka lang. Alright, let us have some examples. Let's evaluate this limit. Ito ay isang polynomial function. According to our previous theorem, kapag polynomial function, what we just do is we substitute. So, you just substitute 2 to x. Let x be 2, you have 2 times 2 squared minus 5 times 2 plus 3. And if you simplify, you'll have 1. And that is the limit of our function. Okay? Next, let's have this. Evaluate the limit of x squared plus 2x over 2x plus 3. We have limit of a quotient. Anong sabi ng ating previous theorem? Ang limit ng quotient ay quotient ng limits. So, limit siya ng numerator over limit ng denominator. And then, itong function natin sa numerator at function sa denominator, they are both polynomial functions. Kapag nag-i-evaluate ng limit ng polynomial function, what do? We just substitute. So, you just let x be 3 here and let x be 3 here. You'll have sa taas 3 squared plus 2 times 3. So, you have 2 times 3 plus 3. If you simplify, you'll get 15 over 9. And in lowest terms, that is 5 over 3. Okay? Next, kunin naman natin ang limit as x approaches 1 of cube root of 2x squared plus x plus 5 all over 3x squared plus 19x plus 5. Okay? Kapag may nth root tayo, may radical, anong ginagawa natin sa limit? Pwede natin siyang ipasok lang. So, itong limit na to ipasok natin. And then we have a quotient. Limit of a quotient is quotient of the limit. So, pwede mong i-distribute yung limit sa numerator and sa denominator. And then, itong functions natin sa numerator and denominator, they are both polynomial functions. Ibig sabihin, kapag kinuha mo yung limit, you just substitute 1 to x. So, substitute lang natin, we have cube root of, sa taas, 2 times 1 squared plus 1 plus 5. And sa baba, you have 3 times 1 squared plus 19 times 1 plus 5. If you simplify, sa taas, meron kayong 8. Sa baba, meron tayong 27. And if you take the cube root of 8 is 2. Cube root of 27 is 3. So, the final answer is 2/3. Alright, I hope clear ito. Next, let us now consider this this limit. So, this limit of a quotient, no? Tingnan natin kung kaya natin yung quotient of a limits. Okay, what we have been doing so far is we've been substituting lang. So, tingnan nga muna natin kung kaya nating masubstitute yung 3kx dito. So, substituting 3 to x, what will we get? We get 2 times 3 squared minus 5 times 3 minus 3 all over 3 minus 3. Yung taas, you have 2 times 9, that's 18, minus 15 minus 3. Sa baba, you have 0. And then, sa taas, you'll have 0 as well. So, you have 0 over 0. And 0 over 0, this is not a real number. And this is called an indeterminate form. Ibig sabihin dito, hindi nyo pwedeng gamitin yung limit of a quotient equals quotient of limits. Tapos, gamitin nyo yung direct substitution dahil polynomial lang. Kasi ang makukuha nyong value ay hindi real number. Pero indeterminate form, 0 over 0. So, ang tanong, paano natin sinosolve yung gantong uri ng limits? To solve this, we have the following. So, direct substitution cannot be applied. So, what we use is the following, what we call the replacement theorem. What does this say? This says that if you have a function f, which is equal to a function g, everywhere except when x is a, and if the limit of g of x exists, then equal na yung limit nilang dalawa. Okay? So, ulit, you have a function f equal to a function g of x everywhere except when x equals a. Tapos, ang limit daw ni g of x nag-e-exist eh. Ibig sabihin, nag-e-exist na rin yung limit ni f of x at equal yung limit nilang dalawa. So, paano natin ito maa-apply sa ating problem? Alam natin na ang value nito when x is 3 is 0 over 0. So, direct substitution cannot be applied. Pero ang gawin natin, hanap tayo ng function. So, this is your function f. Hanap tayo ngayon ng function g of x equal to this function everywhere except when x is 3. And then, kunin natin yung limit ng function na yun. Kapag yung limit ng function na yun nag-e-exist, then equal na yun sa limit ni f. Equal na yun sa limit nito. Okay? Kung nalilito, illustrate natin. So, observe natin when x is not equal to 3, eto, saan kaya to equal? Equal to sa, yung taas can be factored as follows. It's 2x plus 1 times x minus 3. Yung baba, ilabas lang natin sa negative. So, you have negative of quantity x minus 3. So, pwede natin i-cancel sa x minus 3 sa taas at sa baba. And you are left with negative of 2x plus 1 or negative 2x minus 1. So, ito, equal dito everywhere except when x is 3. Anong sinasabi ni replacement theorem? Sinasabi ni replacement theorem na yung limits nila as x approaches 3, equal na rin. At ito, kayang-kaya natin to i-evaluate. This is just a polynomial function, so you just substitute 3 to x. Letting x be 3, what you'll get is negative 2 times 3 minus 1 or negative 7. And that is your limit. Okay? So, anong ginawa dito? Kasi, when x is 3, you'll get 0 over 0 eh. Indeterminate form. Kaya, naghanap ka muna ng, sinimplify mo muna ito, hanap ka ng function equal to this one for all x except when x equals 3. And then, yung limits nila, pareho na. Alright, let's have another example. Consider this function. Again, gawin muna natin, let x be 0 muna. Scratch muna, no? Sa taas, ano yung magiging sagot? When x is 0, you'll have square root of 2 minus the square root of 2. So, that's 0. At yung baba, clearly it's 0. So, still, this is indeterminate form 0 over 0. I-comment nyo lang sa gilid, no? Parentheses, tapos ano yung value niya when x is 0? Indeterminate form 0 over 0. So, gawin natin ginawa natin kanina. I-simplify natin ito. And then, yun yung kukuhanan natin ng limits. Okay. So, ang square root of 2 plus x minus square root of 2 over x, paano kaya natin ito masisimplify? Okay, if we have radicals, our goal is to get rid of the radicals. At paano natin matatanggal yan? Square root lang naman ito. What we'll do is we multiply the conjugate. So, we multiply to the numerator and the denominator. Ano ba yung conjugate nito? It's square root of 2 plus x square root of 2, and then negate nyo yung gitna. So, plus. kailangan nyo yun i-multiply sa numerator at dahil minultiply nyo sa numerator, i-multiply din sa denominator. Para essentially, what we are multiplying is just 1. Okay, so ano mangyayari sa numerator? Mag-i-square ito, so magiging 2 plus x minus square nito. So you have 2 plus x minus 2 all over sa baba copy lang natin. And then yung taas, anong nangyari? Makakancel si 2. So you'll have x over x times the quantity square root of 2 plus x plus square root of 2. And then, since x is non-zero, we can cancel out x and we'll have 1 over square root of 2 plus x plus square root of 2. Okay? And then, by replacement theorem, yung limit nito equal lang sa limit ito. So we have the following. At dito, substitute na lang natin si 0 kay x. You have 1 over square root of 2 plus 0 plus square root of 2. And if you simplify, that is 1 over 2 square root of 2. Baka nagulat kayo na bakit pwedeng i-substitute na lang si 0 kay x. Medyo shortcut ito. No? This is limit of a quotient. So, quotient of limit. So, limit ng 1 over limit ng baba. Limit ng 1 is 1, so 1 na yan. Yung limit ng baba, you have a sum. So, pwede nyo i-distribute yung limits. So, sum of limits. So, you have limit of square root of 2 plus x. Radical yan. Pwede nyo ipasok yung limit. So, square root ang limit of 2 plus x. 2 plus x is polynomial. So, substitute lang. Tapos, ganun din dito sa square root of 2. Kaya, in the end, what we did essentially was we just substituted 0 to x. Okay? So far, ang ginagawa natin, ano yung trend ng ating examples? Kapag 0 over 0, sisimplify nyo ito to something na kapag nilimit nyo, real number na. So, anong ina-expect natin? Ina-expect natin na magka-cancel out tayo ng some expression. This time, x ang ating kinancel out. Actually, yung kinakancel natin dito, yung nagpapa-0. Ano ba yung nagpa-0 kay taas? Yung x din. Nagpa-0 sa baba, si x din. So, ang kinakancel out natin usually yung x minus kung saan siya papunta. So, x minus 0. So, dito, ang kinancel out natin ay x. Sa previous example, ang kinancel natin ay x minus 2. Alright? Let's have our next example. X cubed plus 8 over x plus 2 as x approaches negative 2. Okay? Ganun ulit. Subukan muna natin i-substitute si negative 2 kay x. Pag sinubstitute natin si negative 2 kay x, ano yung taas? You have negative 2 cubed plus 8 or negative 8 plus 8, that is just 0. At yung baba, negative 2 plus 2. So, 0 din. So, this is still indeterminate form, 0 over 0. So, ano ulit gagawin natin? Isi-simplify natin ito to a function na kapag kinuhanan natin ng limit, ang limit nun, as x approaches negative 2, nag-exist na. Okay. Yung, anong ina-expect natin? Ina-expect natin na ito, isi-simplify natin, tapos, along the process, may ika-cancel out tayo. Ano ina-expect natin ika-cancel? It's x minus negative 2 or x plus 2. Yun yung nagpapa-0 sa ating numerator and denominator. Tingnan natin paano natin maka-cancel out yun. Let us first recall the following. Recall yung factorization ni a cube plus b cube. Paano nga natin ito fina-factor? It's simply sum of cube root nito, so a plus b, times square nito, and then product ni a and b, tapos negate nyo. So, imbis na positive, you have negative ab, plus square naman ng second term, so plus b squared. Okay? So, we use this factorization para kay x cubed plus 8. So, sa x cubed plus 8, ano yung factorization niya? It's x plus 2 times square nito, x squared, product, and then negate, so minus 2x, plus square nito, plus 4, over x plus 2. And since x is not equal to 2, si x plus 2 hindi 0, at pwede natin sila i-cancel out. Okay? At yung sinasabi ko kanina, no, yun yung in-expect natin ika-cancel, yung x minus negative 2. So, kapag kinancel yan, anong matitira? It's x squared minus 2x plus 4. And by replacement theorem, ang limit ito equal sa limit ito. At ano ang limit ito? Polynomial lang, so you just substitute. Let x be negative 2. What you'll get is 4 plus 4 plus 4 or 12. And that is the limit of your function. Alright? Let's have another example. So, this time, limit ng square root of 3 minus x minus 1 all over x minus 2 as x approaches 2. Again, first step is to try to substitute, scratch lang, let x be 2. Sa taas, ano mangyayari? You have square root of 3 minus 2, that's square root of 1, minus 1, so that's 0. Sa baba, it's clearly 0 then. So, still indeterminate form 0 over 0. So, may manipulation pa tayong gagawin. Anong gagawin natin? Is-simplify natin to. And then, we expect to cancel out. Ano ika-cancel natin? X minus 2. Okay, paano natin to isi-simplify? May radical tayo. So, again, katulad ng ginawa natin sa isang example kanina, we get rid of the radical by multiplying the numerator and the denominator, its conjugate. So, ano yung conjugate nito? It's square root of 3 minus x plus 1. Multiply natin sa numerator. Ang numerator magiging square ng square root of 3 minus x is 3 minus x minus square ng 1, so minus 1, over product lang ng denominators. Yung taas is 3 minus x minus 1 or 2 minus x or negative of x minus 2 all over yung denominator natin. At again, sabi ko kanina, no, ang ina-expect natin i-cancel out is x minus 2. So here, we cancel out x minus 2. We are left with negative 1 all over square root of 3 minus x plus 1. And by replacement theorem, ang limit nito equal na sa limit nito. So limit niyan equals sa limit nito. At dito, pwede na natin agad-agad i-substitute si 2 kay x. And substituting 2 to x, what we'll get is negative 1/2. This one is square root of 1 or 1. Alright, next, let's have this example. Limit the cube root of x minus 1 all over x minus 1 as x approaches 1. Okay, first step ulit is to let x be 1. Scratch lang, no? Let x be 1. Yung taas ay cube root of 1 or 1 minus 1, so 0. Yung baba ay 0 din. So, still indeterminate form, 0 over 0. Kaya naman, ang gagawin ulit natin ay, ito ay isi-simplify. Tapos, we expect to cancel out, x minus 1. Okay? So, before that, let's recall the following. Kanina, ni-recall natin na ang a cube plus b cube can be factored as follows. So, from here, ano naman yung masasabi natin kay a plus b? Si a plus b, pwede natin tingnan as a raised to 1/3 cube, tama? Plus, yung b naman, pwede natin tingnan as b raised to 1/3 cube. So, meron na tayong sum of 2 cubes. Tapos, gamitin natin to. So, dito, yung a mo originally ay a raised to 1/3, yung b mo napalitan ng b raised to 1/3. So, ano yung factorization nito? It's a raised to 1/3 plus b raised to 1/3. Yung cube root nito, no? So, ito, tsaka ito, times square nito, and then, product nito, tapos negate, so negative a raised to 1/3, b raised to 1/3, plus square nito, plus b raised to 2/3. Equivalently, kapag naka-radicals tayo, what we have is a plus b equals cube root of a plus cube root of b times, ito ay cube root of a squared minus cube root of ab plus cube root of b squared. Okay? So, ito yung factorization ni a plus b. Gagamitin natin to para ito ay mas-simplify. Now, if x is not equal to 1, we have cube root of x minus 1 all over x minus 1 equal to what? Okay. Pag may radical, ano sabi ko kanina, our goal is to get rid of the radical. Ngayon, ang radical natin, cube root. Hindi lang square root, no? Pag square root, madali lang, you just multiply the conjugate. Pag cube root, ang goal mo ay alisin yung cube root. So, tingin tayo dito sa ni-recall natin kaninang equation. Anong meron tayo? Meron tayo ay ito. Kung saan yung a mo ay x, yung b mo ay negative 1. So, ito yung meron tayo. Gusto mong alisin yung cube root. So, what you do is you multiply something of this form to get a plus b. Ano yung a natin? It's x. Yung b natin, negative 1. So, kapag nag-multiply kayo ng ganitong form, what you'll get is x minus 1. Ano yung i-multiply natin? Yung square nito, so cube root of x squared. Yung product ni cube root of x and negative 1, and then negate, so plus cube root of x, and then square nito, so plus 1. Minultiply nyo sa taas, i-multiply nyo din sa baba. At kapag etong dalawa, ito, tsaka ito, minultiply, what will you get? You'll get precisely ito. Where a is x and b is negative 1, so taas mo ay x minus 1. At yung baba, copy mo lang, x minus 1 times cube root of x squared plus cube root of x plus 1. And since x is not equal to 1, x minus 1 is non-zero, and you can cancel them out. Yan yung ina-expect natin i-cancel, no? Yung x minus 1. And this is now equal to 1 over cube root of x squared plus cube root of x plus 1. So the limit of this one is equal to the limit of this one. At paano kunin yung limit nito? You just substitute 1 to x. Letting x be 1, what you'll get is 1 over cube root of 1 squared plus cube root of 1 plus 1. And if you simplify, what you'll get is 1/3. Okay, so I hope clear so far yung examples natin. Let us just summarize paano tayo kumukuha ng limits. First thing you need to do is you just substitute, no, kung saan papunta si x. So, kapag kinuha mo si limit na f of x as x approaches a, tingnan mo muna ano yung f of a. Kapag real number na siya, yun na yung sagot. Otherwise, pwede siyang maging indeterminate form 0 over 0. Kapag ganon, you simplify, and then you try to cancel out x minus a. Okay? Kung may tanong kayo, pakisulat muna, and then you may ask your respective discussion teachers later on. And para ma-practice kayo, you may evaluate the following limits. Alright, that's it for this topic. See you later for the next lecture. Bye-bye!